welcome back. In this video I'll be solving Leetcode problem 146 LRU cache. Okay, this is I think famous problem. Design that was of the least recently used cache. Equals to size capacity, return the value of key, the key exists. Okay. Okay, so when the cache is full, we need to remove the least recently used. But we need off one. Okay. Well, let's think about it. We have first, we need to get in of one. That seems quite easy using hash map or dictionary. So we just store key and value, and if we have it, we just return it. Let's forget, but for put, so we need to update, but we also need to check least recently used, and for this we will have to use linked list so we can track and move the one that was, in example, used some time units ago, if it's used again, to the first. So okay, this is our overview. So let's try to get it. So I'll just take capacity. Since I need to know where currently node is, or when it was previously used to update it, or do I need to know that? Well, I need to know it either way. I can delete it and then put it in again or whatever. We will play with that, but yeah, let's have key to node will be dictionary, and let's also have for the linked list, I'll get two nodes. Let's make linked list first, class node. Initialize self. So key value. Key is equal to key, self dot value is equal to value. Let's keep it val. Self dot next is none. Self dot previous is also none. And I'll define two let's say dummy nodes, which will make easier updating the LRU part. So head and tail. Head is node, so let's use 0, 0. So tail is equal to node also 0, 0, and I will connect them. So self.head.next is equal to self.tail. Previous is self.head. So something like this, so they're connected. And let's try to do get. So if key is not in self dot key to node, then I return -1. If it is, so if it exists, then I need to update it to be used and take the value. So well, let's make some insert at tail and just remove. So what do I need to do? What I want to do, I want to insert it at tail again, but then I want to remove it. Or I can update the node. Well, I need to remove the connection either way, so I'll use self node, so self dot remove self dot key to node of key, but first I need to store the value. So I keep the value, I delete and update the connections, and then I put it at the tail. So insert new node key is key, value is value. So if key not in self key to node, and here I just return value. Okay, and what about put? So to put it, I'll do actually the same thing. So I will delete it if it exists. If it does not exist, I just put it in. So if key in self dot key to node, remove, I need to do the same thing. Self remove, self key to node key, okay. And I need to no, I need to just insert. So insert at the tail again, node with key value, but for the capacity part, length of key, if length of key self not key to node of key to node is greater than self not city, then I have to self dot remove self dot next, something like this. So I remove from the beginning. If it is, I remove it. If it's not, either way I insert it, and if there are too many of them, I delete. Okay, now let's do the interesting part. So when we insert at tail, so I get a node, node dot previous will be self dot tail dot previous, self dot tail dot previous dot next will be node, and node dot next will be self dot tail. So previous is node next is tail and sub dot previous is node. So this is, I think, it. And if I insert a tail, I'll need to update sub dot key to node of node dot key. If it doesn't exist, I just update it with itself. Okay, I think that's good. And for the remove part, we need to do the classic. So node.previous.next is not node anymore, but node next. Node.next dot previous is node.previous. So that part is done. Node previous next is not next previous is not previous. Okay, and I just need to delete the key. Yeah, I think I just need to delete the key. So delete key to node. So dot key to node of key. That should be it. Let's check this one out. Node key. Okay, looks good. And it works. Nice. So, not so easy one. Let's go through it again. So there are two parts of this problem. One part is well, we need to have get and we need to have put in of one average time complexity. To get something in of one average, we need to have a hash map. So I need to store nodes or nodes values in that hash map by the key. So I check if key exists. If it exists, then I return it in of one. Second part is put. Put also in get. There is part with least recently used. That has to be done. Well, I did it with double linked list. So each time I let's say use or look for the node, I push it to I remove it from the linked list and put it at the end of the linked list. So that's essentially that part. And how did I do it? So I had key to node, I added head and tail to make easier inserting and removing, because now I don't have to check if there is node previous and so on, or node next. I'll always have them. And how do I get if there is not key in my key to node? So I have a hash map that maps keys to full nodes. So I just return, I take the value, I remove the node, and I add the node again. And for the put, if node already exists, I have to update it, I just delete it, and I insert at the end. And when I insert, I check if we have over capacity nodes and remove them. And now inserting and removing. So when I insert, I inserted tail. So I update the last nodes with new node, and I update the new node with next, previous, and next, and I update the tail, and I add a new key or update the key, whatever happens. Update the key to node hash map. And for the remove, I just reconnect the node without the one that is being removed, and delete the key from the hash map. So yeah, time complexity, well, Off one, off one. I think nothing too smart. Yeah, off one, off one. Space complexity is of capacity. Yeah, that's correct. Okay, let's write that down. So off one from task and space of capacity. So yeah, pretty interesting problem. So good to be informed about, and I think this type of problems are sometimes on the interview, so it's important. Okay, if you have any questions for this one, leave them in comments. I thank you for following, and see you in the next one.